Hello all, EMI EMC compliance is a very important part in embedded designs. If you want to release your product to the market without any issues, and if your product has to be certified for EMI EMC, you have to follow specific guidelines in your circuit, or if you do not follow these or ignore these guidelines, you might go for a compliance of your product and then you might have to come back, adjust your circuit, and this might lead to the longer product cycles, thereby increasing your product costs. Right? Simple. Right? Now, let us take one scenario where we have a connector, okay, and then from this connector we have a signal that is coming inside the PCB. There is a requirement of a cable or external cable to be connected to this connector on the PCB, which further interfaces to another system. So this is one scenario. Okay, in this scenario, what happens is there might be some interference that might be entering the PCB from this particular connector through the cable that is connected outside. How do we eliminate this? Simple question, right? This is one of the biggest problems the EMI EMC guys face, or the electrical designers or the embedded designers face, and it's very difficult to catch. Let me tell you. Okay, so now in these scenarios, you can have a series component here which passes only the frequency which is required and eliminate all the other frequencies or block all the unwanted frequencies which come through the external cable to this connector and enters the PCB, right? So what could be those components? Okay, now two main components which designers use worldwide to block those frequencies are: one is simple low pass filter, which is basically an RC filter. Okay, we know, right? RC filter acts as a low pass filter which blocks frequencies beyond certain frequency, right? All the higher frequencies you can use it straight away. You can also use a ferrite bead which shows a very low resistance at normal frequencies, desired frequencies, and it introduces a high impedance at the unwanted frequency. So we have to select the ferrite bead in such a way. So these two are the two simple components that can be used in series with the signals that are entering the connector. Now the biggest question: which should I prefer? Is it ferrite bead or is it RC filter? In this scenario, if you see a ferrite bead, this definitely will have some inductance associated with it, right? But it's a component where it behaves normally at a given at the required frequencies, and it shows only high impedance at unwanted frequencies. But the RC filter, it has two components associated with it, which is R and C. So the resistive element might sometimes introduce oscillations in your circuit which are unwanted basically. Okay, so it is better to go with a ferrite bead in most of the scenarios, unless you could not find a specific bead for your application. It could be that you have to fall back on RC filter. So the first priority would be ferrite bead and the second priority would be an RC filter. So that's how you include in your circuit and prepare for your compliance. So if you have any doubt, please post questions. Please let us know your thoughts about this. Thank you.